In number 29, we have a cube root function. Again, we're asked to graph and state domain and range. Y equals 3 times cube root of x plus 4 minus 9. Let's identify our parameters. Our a value is 3. Our h is negative 4. Remember, the opposite of what we see under the radical. And the k value is negative 9. We can use these values to help us with our data table. hk for a cubic function are the middle value at negative 4, negative 9. Notice if we choose one value before that and one value after that, let me switch the places of those. One value before that and one value after that, we should be able to take the cube root. When we put in negative 5 for x, we get negative 5 plus 4 is negative 1. The cube root of negative 1 is negative 1. Let's multiply that by 3 and get negative 3 and subtract 9. That's negative 12. Those numbers are getting kind of big for us. They might not fit on the graph. Let's go the other direction. If you plug in negative 3 for x, you get negative 3 plus 4 is a positive 1. The cube root of positive 1 is 1, times 3 is 3, minus 9 is negative 6. Again, if you're wondering where we're getting these values for our table, we're thinking about what numbers we can easily take a cube root of. The next number that I know we can take a cube root of is 8. Therefore, what I want under the radical should equal 8. If that's true, then x has to equal 4. When x is 4, 4 plus 4 is 8. The cube root of 8 is 2. Times 3 is 6. Minus 9 is negative 3. It's unlikely that we can find additional values for our graph, but let's just think about it. The next number we can take the cube root of is 27. In order for the radical, what's under the radical, to be 27, x would have to be 23. So that's not going to work out for us. We'll just have to make do with the 4 values that we have. At negative 5, we're at negative 12. A little bit off the graph. At negative 4, we're at negative 9. At negative 3, we're at negative 6. And at positive 4, we're at negative 3. Remember the basic shape of our cube root function. We have these 3 values that our graph is going to go through. And then it's going to go off to get through that other value, and it would go back in the same relative shape and size in the other direction. Let's discuss the transformations. Remember, we're always comparing these against the parent function. In this case, y equals cube root of x. In this case, instead of an a of 1, we have an a of 3, which represents a vertical stretch by a factor of 3. Our h of -4 tells us that our graph is shifting left 4. And a k of -9 says that the graph is also shifting down 9 units.